Hi, this is James Cook of the University of Maine at Augusta in the social science program, and I'm recording this video to talk about the sociology of the coronavirus. Sociology is focused on the idea of social structure, that the pattern of arrangements around us strongly determine the experience that individual people have, that groups have, that communities have, that institutions have, and ultimately that societies have. And so let's think about how social structure can impact the experience of the coronavirus. In a time of pandemic, one of the most abstract academic fields of them all, sociology, can prove to be one of the most applicable. So how much does social distancing work in a time of a pandemic? And how much distancing is needed? These questions are really important. It's a matter of life and death. So let's talk about social distancing and what it's related to. And let's get very particular very quickly. Social distancing means reducing interactions based on physical proximity as much as possible. We're not talking about interaction over Facebook. We're talking about being in the same physical space as a social relation and reducing that social relation as much as possible. That means not coming into contact with other people, coming into contact with as few people as possible. Sociology can provide guidance here. What sociology is the study of the social structure of relations between these things called social objects, which can be varied. So they can include people, groups, communities, institutions, and societies. Today, we're going to talk about people. When we say sociology is the study of the structure of relations, we mean by structure a pattern, an observable pattern. And these social objects are things that can relate to each other. So sociology, understood in this way, can be seen as the study of a pattern of interrelations, which is the essence of social network analysis. Social network analysis has a very simple, fundamental vision of the world. It says there are really just two things: nodes, entities that can relate to other entities, and ties, which are relations between entities. A network is that structure of relations between nodes through ties. So there are just a few basic measures of social networks that we'll talk about today. Of course, there are many other ways to look at patterns in social network structure, but we're going to focus today on three. Degree, the number of ties involving a node. For instance here, A has a degree of 3 because it is tied to 3 other nodes. Through a tie from A to B, a tie from A to D, and a tie from A to C. B has a degree of 2, E has a degree of 1, C and D have a degree of 2 each, and F has a degree of 0 because it has no ties that involve it. You can think about the average degree of a network. So if we have here 1, 2, 3, 4, 5, 6 nodes, and we have a total of a degree total of 10, that is 3 plus 2 plus 2 plus 2 plus 1, that's 10, divided by 6 nodes. To get an average, you would have an average degree of 1.66, or 1 2/3. We can also look at cut points. Cut points are nodes that, if removed, separate what was a connected network or connected portion of a network into disconnected parts. Not all nodes are cut points. For instance, E is not a cut point. If you take E out, the rest of the network is just as connected as it was. If you take D out, node D doesn't connect any parts of the network that weren't otherwise connected. So removing D doesn't change the connectivity of the network, but taking out nodes A and B would, or A or B. You take B out, and all of a sudden E is cut off from nodes A, C, and D. If you take node A out, C and D are separated entirely through a path of ties from nodes B and E. That makes A a cut point, and it makes node B a cut point. Finally, there is a kind of a node in a structure called an isolate. It's a node that is not tied to other nodes. It's a node that has a degree of 0. It's isolated. Node F is an isolate. Sometimes being isolated sounds desolate, right? But when it comes to the spread of disease, being an isolate is a distinct advantage. And that's what we're going to think about today, moving very quickly. How can varying social structure in a social network affect the spread of a virus in a pandemic? Let's vary social distancing, which means the degree that nodes have with each other in physical contact, and find out what happens to other forms of social structure. To do that, I'll be visualizing some networks that are created in the program R, and we will be visualizing them through a program and a package in R called iGraph. So let's start with a randomly generated network of 50 nodes that specifies, however, that for the whole network, we shall have an average degree that equals 5. That means on average, there are 5 ties for every node. You'll notice that not every node has 5 ties. For instance, node 7 has just 2 ties. Node 5 has 3. However, in the middle, there are some other nodes that have many more than 5 ties. On average, however, the degree is 5. What's noticeable here is that there are no isolates. And this is a bad scene for a community of 50 nodes. If the tie that we're looking at here in a pandemic spends time with in physical space, because that's how the virus spreads. The fact that there are no isolates means that there are no individuals who are entirely safe, because let's face it, if you want to stop a virus, the best way to do that is to have nobody spend time in physical space with anybody else. There are also no cut points here. And what is a cut point? Let's review that again. A cut point is a node that when you take it out, or somehow you stop transmission, you stop a relation, you're able to separate one part of the network from another, right? So that they can't be reached from one another. A cut point is a point of responsibility. It's this moment where somebody who is in a physical environment with some other nodes is able to make a decision about how they're in that physical space with others. For instance, they could be at a distance of greater than 6 feet, which is not perfect, but is a pretty good start. And the truth of the matter is that none of us are perfect, right? Sometimes we try to be 6 feet away from one another in the difficult time of the coronavirus pandemic, and we slip up. Or we have to just say, oh, I'll just take a couple of seconds to squeeze my way past this person, and I'll just hold my breath, ignoring that the air we're going through contains the air that they have just breathed. None of us is perfect, right? But in that moment of a cut point, we know that if that person can exercise some diligence If there's a cut point in the network, then that person can, if they are just that one person successful, then by gum, they can protect a whole other portion of a network from the coronavirus. If the coronavirus is on one side of the network so far, but not the other. On the other hand, because we have no cut points here, there is no situation like that where just one person, one individual, right? We focus on American individuality. You be responsible and it will be okay. No, that's what the situation of a cut point. It's created structurally by a cut point. The ability of one individual to do the right thing and make things okay for others. Here, in this network, there is no one person that can just by themselves do the right thing and make the rest of the network safe. If coronavirus is somewhere in this network, a number of individuals are either 2 or 3 or 4 or maybe even 5 of them going to all have to, at the same time, behave responsibly and not slip up and not make a mistake in order for the coronavirus not to spread to the other part of the network. And how likely is that? Certainly not as likely as one individual in the network doing the right thing and not making a mistake. Because people do make mistakes. It's what makes us humans. Now, you might ask, why are we looking at an average degree equaling 5? The answer comes from the General Social Survey, which found in 1985 and again in a later replication a little bit more than 10 years later, that when you ask people, who do you get together to discuss important matters with? Basically, to be a good friend with, that people tended to answer somewhere around 5 or fewer, right? So somewhere around 5 is the set of good friends, good buddies, the sort of people you would hang out with in physical space. So if we do nothing but tend to hang out with 5 people in physical space, just 5, what damage could 5 do? This network tells you. Having no social distancing at all creates a situation in which this virus is going to spread very easily. Even if you spend no time with your acquaintances, just with your 5 good buddies, right? You're in trouble. So, what if you do just a little bit of social distancing and you say, let's cut one person out of that network? Look at what difference it makes. Now, sure, there are no isolates here, but you do notice that there is this dyad, this pair, node number 43 and node number 30, who are themselves separated off and away, all on their own. And you also notice identified in orange here that there are 3 cut points, node 44, node 25, and node 31. Each of those can protect at least one other person, and sometimes more than one, by doing what? Just themselves individually doing the right thing, which, as we've discussed, is a whole lot easier than getting a bunch of people to do the right thing all together. There are some people that can be protected here. Not that many, but a few of them. And that's better than a degree of 5. So maybe you cut that one person that's really not your best friend out of your life for a little while and say, sorry, I'm not going to spend time with you. This is better than nothing, but you still could do better. With a set of 50 people, it's still not looking good for most people in this network. They're going to catch the coronavirus. They're going to succumb to this pandemic. What if you make a degree of 3? Now we've got an isolate. 38 is on the safe side, and this is by randomly generating ties when we set the average degree equal to 3. We also notice that there are now 6 cut points. 6 individuals who, by being really careful about the physical distancing, say maybe more than 6 feet, and washing their hands, maybe by wearing a mask, so that when someone coughs like I just did, it isn't spread. Well, there's more ways that people can be protected and made safe here. And that the spread of the virus from one section of the network to the next can be averted. It's still not perfect, though. You've got to do more if you really want to make this network even a little bit more safe. Look at all the opportunities for spread here. And this is just in a network of 50 nodes. There's still too many. This is why people are saying you've got to do more than that. How about if you just hang out with two friends? Well, you might be in luck here. You have a dyad, 43 and 28, who are connected to each other, but to no one else. They might be pretty safe. Then there's, wow, 7 isolates. These are indicated in blue, nodes that are floating off by themselves. And you have, because you have variation in a random network, you have 9 cut points. Points that separate one part of the network from the rest. These are individuals who, if they're responsible, they can prevent other people's deaths, other people's infection. They can prevent spread. It's starting to look good. It's not perfect yet still, but it's a heck of a lot better than when we have the average degree equaling 5, which is typical for friendship networks. Just get together with your friends. This is a certain spread, and it's going to go quickly. This is a spread, if you get down to 2, where some people are pretty well protected in perpetuity, and others, well, if they do the right thing, they might protect some others. And still, others, you'll notice, if it's going to spread from one zone to another, it's going to have to go through a larger number of people. And that means that the spread is going to be slower, but we can do better than that. What if you just spend time with one other person? Well, this is really good. You have a number of dyads, 20 and 26, 24 and 38, 5 and 37, 47 and 35, 9 and 33, and 49 and 39. That's 1, 2, 3, 4, 5, 6 dyads that are just separated with each other. Then you have a whole bunch of isolates, 18 of them. And when you have these two larger networks, there are a bunch of cut points in between where if one individual doesn't do the right thing and slips up, there's someone else along that path that can stop the coronavirus cold. This is a lot safer. Now, before we go to complete disconnection, we could have a situation where on average, there's an even lower degree. What if we say average degree equals 0.4? That is, 40% of the time, some kind of connection exists. Well, you've got a lot of dyads. You have just one triad with a cut point in the middle, and then you have a bunch of isolates. That is almost as perfect as if the average degree is 0. No one is in contact with anyone else. We're all very lonely, but nobody's going to get sick with this virus. This experience going to 0 or 40% of people having a tie on average, or on average everyone having 1 and 2 and 3 and 4 and 5, is a visual representation of just how stark the difference is when you do some mild, moderate, extensive, severe, or total social isolation. Total social distancing is the best. Even just a little can do so much. And when we're talking about life and death of a number of people around you that otherwise you would be either directly in contact with, or you would know them through a friend of yours, these are people who you're acquainted with or who are directly your friends. If you want to take care of them, don't see them, because if it's like a match going into a set of pine needles here with business as usual with your best friends, it's just going to go badly for everybody. Here and here with 1 or none, or somewhere in between, you can have safety. Now, is it possible that this whole set of 50 nodes that I picked is some kind of trick? In order to figure that out, I want to show you a result of some more extensive random generation of networks to look at these effects. The x-axis is the average degree in a network. The y-axis is the number of nodes of different sorts, either cut points, which are good, isolates, which are really good, or others, those that are more connected, which is bad. And then there are all these dots there, and each dot represents a random generation of a network of 50 nodes, which is in this graph, and I'm setting different values of average degree for the random generation of ties within those nodes. Either a degree of 5 on average, of 4, of 3, of 2, of 1, of 0.4, or none at all. And every dot is a random network. And we can see here that as you are way up toward 5, you're going to have hardly any cut points or isolates. They're very rare. 4, you have a few more. 3, you have a few more. 2, you have more. And then there's this weird crossover because as you go really low, the number of cut points goes down because there's no connections to separate, right? And everyone's isolated. But if you take isolates and cut points put together, there's a lot of them when you get down to 0 or 1. What's really disturbing is others. Others are nowhere when you get down to 0. They're moderate when you're at 1, and they go disturbingly high when you're at an average degree of 2, 3, 4, or 5. Now, I want to show you some additional graphs that are, by the way, these are showing trend lines. These lines, it's showing the general pattern, the black for the black dots, the orange for the orange dots of cut points, the blue for the isolates. It's showing you the general trend of how the pattern works. Let's see what happens if you generate networks of 100 nodes or 500 nodes. Let's go up to 500. Why not? 10 times larger. The pattern is the same. The only thing that changes, because we're looking at more nodes, is that the overall tendency is tighter. So there's a lot of variation here in 50 nodes. But when you get up to 500 nodes, because you have the generation of hundreds of ties, the general tendencies tend to tighten up. But the pattern is remarkably similar. The pattern is the same when you get up to 5,000 nodes per network. Okay, so you actually have, in this case, you have 6 different values of degree. You have, for each, 5 different networks generated for each point, just as you did for 500 and for 50. So each of these graphs is showing runs about 30 networks. And the pattern is the same. The pattern is the same when you go up to 50,000 nodes. And what if you go all the way up to 500,000 nodes? This is a major city. The pattern is the same. The only thing that's different is that when you're working with so many nodes and so many ties, the tendencies with the number of cut points, the number of isolates, and the number of large degree nodes really focuses around very particular points. Which means that this is a trend that is not dependent on how large the network is. It applies if you're in a crazy small town, a really small town, a pretty small town, a moderate-sized burg, or a metropolitan center. If you want to decrease the number of nodes that are not cut points or isolates, and therefore are not only not protecting themselves, but not protecting others, you have to go way down in the number of people that on average people are seeing. 2 is better than 5, but if you really want to do well, get down to 1 on average. Get down to half a person on average. That means maybe 1 out of every 2 people is connecting. You can get down to 0. It can make the difference between this mess of a viral spread, like a match thrown into pine needles, this kind of slow burn, or ideally a situation where it hardly spreads at all, or perhaps if we give it a couple of weeks, just stops cold. It's the difference between life and death, and social structure in social networks can explain that difference.